main thing what exactly happening in the sintering is one of the treatment process. Okay, so it is one of the treatment, especially it is a thermal treatment process. So why we going to call it as a thermal treatment means the things will be heated over here. Okay, below its melting points, we're going to heat out the things. Okay, so we're going to tell why is it really necessary for the heating out the process and all. Okay, so we're going to give the explanation for this in this class. What exactly the sintering and what are the types of sintering and how it will be affecting the particles. So when you know the exact definition of sintering is, so it's the thermal treatment of a powder. Okay, so it is nothing but the thermal treatment of a powder or a compact at a temperature below the melting point of a main constituent. Okay, so in case of this sintering, we're going to heat out the particles below its melting point. Okay, so it is called as one of the thermal treatment process where the powder or particles have been heated below its melting point. So for the purpose of increasing its strength by bonding together of the particles. Okay. So our intention of doing this sintering process is to strengthen the particle. Okay. So in order to get the good bonding between the particles which are present adjacent over there and to join each other. Okay. Because of that, we'll be taking over the sintering. Okay. So this is the broad definition for the sintering. Okay. So it's the thermal treatment of a powder or compact at a temperature below the melting point of the main constituent. So for the purpose of increasing its strength by bonding together of the particles is called as the sintering. Okay. So you guys have read on the definition as usual. So if you check out the what are the main important types of sintering. Okay. So we're going to have the solid state sintering, we're going to have the liquid state sintering, and we're going to have the reactive sintering. Okay. So in case of the solid state sintering, only solid phases are present at the sinter temperature. Okay. So in case of the solid sintering, so only solid phases are present at the sinter temperature. So whereas in case of the liquid phase sintering, a small amount of liquid phase are present during the sintering process. So whereas in case of the reactive sintering, particles react with each other to form a new product phases. So these are three different types of sintering process: solid state sintering, liquid phase sintering, and the reactive sintering. So what exactly is going to happen during the sintering? That was the thing over here. Okay. So if you're going to check out the diagram, okay. So it's the before a sintering process, this is after the sintering process. Okay. So you guys can check out the particles. Okay, how it has been bonded together over here. Okay. Because of this bonding is going to occupy the large space in between the particles. In other words, called as a pores. Okay, the large size pores have been present. So if you want sinter out the particles over here. Okay, so what happens after the sintering? Okay, so in this case, see the neck formation will be takes place. The neck formation will be takes place. So apart from that, okay, so the grain boundaries will be formed over here. Okay, the grain boundaries between the two grains, the boundary will be formed and it will be compressed. Okay, and apart from that is the pore size has been reduced over here. Okay, after the sintering process, pore size to some extent it has been reduced or else it has been minimized over here. So that was the diagram which you guys has been showing over here. Okay. So this is the purpose of the sintering. Okay. So if you're going to go do the sintering operation means, so the pores will be reduced. In other words, it will be minimized. The neck formation will be takes between the particles. Okay. So that's what has been written over here. So atomic diffusion takes place at the welded areas formed during the compaction grow until eventually they may lost completely. Okay. So once we're going to do the sintering process, the compaction will be takes place. Because of this compaction, so the particles will be attached to each other, leading to formation of the layer. Okay. So recrystallization and the grain growth may follow. Okay. In the second step, you guys can able to check it out. The recrystallization and the grain growth may follow, and the pores tend to become rounded, and total porosity as a percentage of the whole volume will be tends to decrease. Okay, after sintering process, the porosity will be decreased. Because of that, why we are suggesting the doing the sintering process. So in the pressing operation, the powder particles are brought together and deformed at the points of contact. So at elevated temperature, the sintering temperature, the atoms can move more easily and quickly migrate along the other particle surfaces. So that is the called as the diffusion process. Okay, as the temperature has been increased, the particles will be adjoining to each other, leading to the diffusion. Diffusion nothing but the joining of the particles together by forming a small grain boundary. So metals as of contact. So depending upon the types of sintering process, okay. So the different things will be happening over here, okay. So these are the things going to be happened once we're going to do a sintering process on any type of particles or powders. So apart from that, okay, why we need this sintering means in order to increase the strength of the powders, in order to increase of the hardness, to check out the electrical and thermal conductivity, permeability of gases and the liquids, to have the average grain numbers and the size and the shape of the particles, to obtain the good distribution of the grain size and the shape, average pore size and the shape, distribution of pore size and shape, the chemical composition and the crystal structure. Okay. So because of these things, we need the sintering process over here. Okay. So by doing out the sintering process, all the things, the hardness, it may be the strength, it may be the particle distribution, it may be the chemical composition, it's going to improve a lot in this process after the sintering process. So is it clear the definition of sintering? So is it clear the definition of the sintering?
Yeah.
So this is about the concept of the sintering process and why exactly the sintering process has been required for the before it's going to be having the testing over here. So in this case, we're going to check out the types of sintering. In that, the first one is the solid state sintering. Okay. So in these types of sintering, the first one is the solid state sintering. So what exactly the solid state sintering means? So in case of the solid state, as the name itself it suggests, okay. So at the during the time of the sintering process, okay. So once the finished components has been obtained, okay. So it will be in the form of solid itself, okay. So there will be no liquid or semi-liquid during this process of the sintering process, okay. So in the solid state sintering can be divided into three important stages over here. So you guys can able to check out the things over here. In case of the solid state sintering, this process will be happening. So as we have been shown out the diagram for you guys. So this is the particles in contact. Okay, it may be 4 particles over. It may be more than 4 or n number of particles. Let it be. Okay. So these are the pore how it has been formed during the process. So during the sintering process, the neck formation will be takes place between the particles. Apart from that, the pore size will be reduced because of the large grain boundaries over here. Okay. So this is the final sintered geometry. Okay, compared to the initial sintered geometry before sintering and after sintering, the strength will be quite high for the final sintered geometry. Okay, so coming to the stages of the solid state sintering process. So in the first stage, because of the heating, the necks are formed at the contact points between the particles, so which continue to grow during the rapid neck growth takes place. All these pores are interconnected and the pore shapes are irregular. Okay. So during the first stage, the neck formation will takes place between the particles and it will continues to increase the size of the neck during the first stage of the particle. During the second stage, okay, in the second stage, the sufficient neck, okay, so the final neck growth will be takes place and the pores almost it's in terms of the cylindrical in nature. Okay, the shape will be almost in terms of cylindrical in nature. So as the neck grows, the curvature gradient decreases and sintering also decreases. As the neck grows, the sintering process also be decreases over here. Okay, so the pores continue to form connected face throughout the compact. Okay, so throughout the compact it will continues to form a kind of connected face throughout the compact. And this is the third and final stage. The pore size will be reduced compared to the first size After doing the sintering process, the final sintered geometry, the shape will be quite different, and the size will be reduced because of the compression, because of the heated to the higher temperature, and because of the good bonding between the particles. The pore size will be reduced over here. Okay, so these are the three different stages of the solid state sintering process. So in case of the liquid state sintering, okay, this is the solid state sintering, this is the liquid state sintering, okay. So the main difference, you guys can able to check it out, okay. So in case of solid state sintering, only solid things will be there during the sintering process, okay. So whereas in case of the liquid phase, some amount of liquid will be formed during the process, okay. So sintering in presence of the liquid phase, what exactly happens over here means the composition of the starting material is such that that generates a small amount of liquid phase over here, okay. So it can able to generate small amount of liquid phase on heating. So in case of the liquid phase sintering, the small amount of liquid phase will be obtained during the sintering process, okay. So what exactly happens is the liquid should be able to dissolve a small amount of the solid phase, okay. So it should have the capability to dissolve the small amount of solid phase, and thereby form the wet the surface of the particles, okay. So there will be solid and liquid at the faces surfaces during the process, okay. So in case of liquid phase sintering, it is a combination of solid and liquid process over here, okay. So that is the main difference between the solid state sintering and the liquid state sintering, okay. So in the liquid state sintering, the liquid particles will be obtained during the sintering process, and it will be make wet throughout the particles over here. So this is the solid state sintering process, this is the liquid state sintering process. As the name itself it indicates, so what exactly is going to be happened over here. So apart from that, okay, solid and the liquid state, we have the third important type is the reaction sintering, okay. So we're going to tell what exactly the reaction sintering process, okay. So the reaction sintering is a special form of rapid sintering technique, okay. So it's a fast processing method of sintering technique. So to process the high temperature materials resulting from a chemical reaction between the individual constituents, okay. So in this case of the reaction sintering, as the name itself indicates, the chemical reactions will be takes place between the two individual constituents in order to obtain the good bonding strength between the particles. So the reaction sintering takes place when two or more components chemically react during the sintering process to form the final product. Okay, so these are the main differences between the solid state, liquid state, and the reaction sintering process. Okay, so in case of the reaction sintering, because of the chemical reaction, that will be bonded together over here. So that's the thing happening in the reaction sintering process. So the next will be the structure and property changes studied that during the sintering process. Okay, so during the sintering process, what structures will be changed and what are the properties that is going to be changed over here. Okay, so the main purpose of sintering is the densification of the compact powder. Okay, so in order to make the densification of the compact force powder, so the densification is reciprocal to the shrinkage or the amount of pores removal in the case of single component system. Okay, so the main important property that's going to be changed during the sintering process is, so the amount of pores will be removed completely during the component of the system. So in the case of multi-component system, so such as the pre-mixed powders during sintering, solid solutions may form the resulting in the expansion rather than the shrinkage. Okay, so hence the densification cannot be treated as equal to the amount of porosity that has been removed over here. So the third important one is the expansion of the compact powder may also take place due to the entrapped gases. Okay, so the expansion of the compact powder will also be takes place because of the small pores in terms of the gas has been filled in between over there. So in case of the powder mixes containing metals having lower melting point, evaporation or volatilization of these elements can occur, and proper care must be taken over here. Okay. So in case of the powder mix, so of the especially the metals, okay, at the low temperature, okay, the evaporation or volatilization will be takes will may takes place. So we have to be avoid those things over here. So other reaction that is going to be changes takes during the sintering is recrystallization, and the grain growth will be takes place, as well as the pore growth will also be takes place if sintering is not carried out for the longer time. So especially sintering has been carried out at a higher temperature, around 1000 or 700 or 900 degrees Celsius. At the same time, the temperature duration of the sintering is also quite high. It is not 5 minutes or 10 minutes. Okay, so it will be in terms of hours, 3 hours, 4 hours, 5 hours. In that manner, is going to be done over here. So as a consequence of the structural changes that takes place inside the thing, so what exactly happens is the mechanical properties, it may be the hardness, it may be the strength, it may be the fracture toughness, it may be the physical and electrical properties. So that has to be tend to be changed. Okay, in other words, it will be increased over here. Okay, because of the things, it has to be increased over here. So these are the structure and the property that is going to takes place during the sintering process over here. Okay, so these are the basic things about the what exactly the sintering, why sintering we have to do it for our powder particles, so especially the ceramic particles. So at the same time, what are the different types of sintering process, so how the stages have been involved, and what is the purpose of the sintering process, what are the changes that are going to take place. It may be the property changes or structure changes during the process. Okay, so these things have been seen out today. Okay, so in the next class, we're going to continue it over here. So we're going to another 2 to 3 important topics in the sintering, and we're going to complete by tomorrow class. Okay. So this is a basic brief introduction about the sintering, the types, and what exactly the things going to happen because of the sintering process and all. Okay.